How y'all doing? My name's Ryan with Blue Sky Energy Solar Charge Controllers, also Genasun Solar Charge Controllers. The Genasun brand is a little bit smaller than the Blue Sky, not very popular with the RV market, except where if you perhaps are replacing a PWM style charge controller on like a portable panel. We'll talk a little bit about that pretty much initially. So today we're pretty much focusing on the Blue Sky Energy products and also just all general questions. I try to keep this kind of informal, so if anybody has a question, raise your hand. I love interaction. Basically, you always want to start off and describing the two different kinds of charge controllers out there in the market today. You've got PWM style charge controllers, which stands for pulse width modulation, and you've got MPPT, maximum power point tracking. Now to put it simply, your average 12 volt solar panel, right? I'll use a lot of air quotations on this because I'd always rather you guys reference the actual specifications than going with general categories because they can get a little confusing out there, even for me. So I always refer to the specifications. But talking about your general 36 cell 12 volt panel, it has an output voltage of around 18 volts under load. Now sun angle, partial shading, stuff like that can affect that voltage, but not by a large mean, not by huge amounts. Now a PWM style charge controller, while in bulk mode, when you're trying to raise the battery's voltage, given everything you got, providing constant current, a PWM style charge controller basically connects the solar panel directly to the battery. Now when you do that, you're forcing your solar panel, which has a potential output of 18 volts, to operate at your battery's voltage. Let's say 12 and a half, whatever your battery voltage is at the time. So you're losing all that power between 12 and a half and 18. What an MPPT charge controller does is it operates your panel at its optimum voltage, and then it does a buck type energy conversion. It's lowering the voltage, but at the same time increasing the current. So you harvest all the power available from your solar panel. Now as you get to the higher voltage panels or higher wattage panels, and they kind of correspond between the two, the higher the wattage, seems like right around 200 is the threshold, then you start getting even higher output voltages from your panel. You're maybe like 30 volts or maybe like 37 volts for what you would call the 72 cell 24 volt panel, right? That's where you get confused. How come a 12 volt panel has 18 volts out and a 24 volt panel has 36 volts out? I didn't invent the rules, right? Just the way it is. So especially as you get into these higher voltage panels, it's really necessary to have a maximum power point tracking charge controller. You guys spend a lot of money on your system, a lot of money on your panels, a lot of money on your batteries. No sense handicapping yourself, you know, with limited output. Any questions? Awesome, pretty easy to understand, right? Now, most of our charge controllers are MPPT. We do sell one that's a PWM, a little bit of a price point. Some people like it, and if you have a smaller system and you're just topping it off, that does it just fine. One thing about our charge controllers is we don't, as far as our charge profile, and I'll talk about the different stages of the charging in a moment, but all of our charge parameters are settable. They're all programmable. Some charge controllers will say, oh, this is my lead acid setting. Oh, this is my lithium setting. This is my flooded setting, right? It's my AGM setting, and they just pick a general setting for it. Now, if you look at different manufacturers' recommendations of charge voltages, they vary quite a bit, even amongst the same battery type. A Trojan T105 wants a different voltage than a Deca. You know, a Lifeline AGM wants a different voltage than a Full River AGM, drastically. And as far as the lithium charge profile, everybody's got their own opinion on how to do it, right? And that's just the truth. You know, some I agree with, some I don't agree with, you know, and I'll talk a little about like lithium charge profiles and some of the pros and the cons about it. In the end, you know, you're always welcome to defer to your manufacturer's recommendations, or you can read a ton of articles and come up with your own opinion, because truth be told, everybody's out there, and I'm even continually learning on, you know, how to charge it and stuff like that, and what the popular opinion is, and so leaving that aside. Generally speaking, you have three different charge modes, right? You have your bulk mode. Now, when we talk about bulk as a mode. You're in bulk mode. A lot of battery data sheets will talk about bulk as a voltage. You know, for example, if you look at the Trojan specs, it'll say float voltage, bulk voltage, right? We don't use bulk, we use bulk as a mode and not as a voltage set point, just to let you know it's out there. Now, the first stage of charging is called the absorption phase. Now, just to let you guys know, it used to be called the constant, then it was called acceptance, now it's called absorption, right? It's a little bit like an AA meeting. But if you guys ever hear about like, oh, I'm in acceptance mode. or I'm in absorption mode. Those are interchangeable terms. Now, talking about lead acid batteries, because we'll get a little bit to lithium in a little bit, right? But talking about lead acid batteries, it's really important to get to that absorption phase in order to properly desulfate your batteries, right? As he was talking about earlier, the sulfation that grows in the plates. Now, to put simply, when you discharge a battery, like a coral reef grows on those lead plates. That's your sulfation, right? And if you charge a battery, the coral reef turns back into acid. It's called soft sulfation. It's totally normal. But the longer that coral reef, that sulfation, lives on those plates, the harder it is to turn back into acid. And that's where you get into never discharge your battery beyond a certain point, right? Because the bigger that coral reef is, the harder it is to turn to acid. You also have the expression, don't leave a battery discharged for a long period of time. The longer that coral reef lives there, the more it crystallizes, the harder it is to turn back into acid. Now, different batteries like different voltages for this proper desulfation. Generally speaking, AGMs tend to be on the lower side, and flooded batteries tend to be the higher. Trojan T105 recommends 14.8. Lifeline AGM recommends 14.3. So it's all over the map. So once you maintain the absorption voltage, right, now standalone, a charge controller usually bases that on time. So if your batteries are fully charged, it might need 2 minutes in absorption. If your batteries have been discharged for a long, long time, it might need 4 hours inside the absorption, in the absorption phase. As an industry standard, standalone, usually controllers are programmed for about 2 hours of maintaining the absorption voltage. Of course, you can change all these settings on our charge controllers depending on what your usage is. The other way to maintain that voltage or base that transition to the lower float voltage, which will be about 13-ish, depending on what type of battery you have, is to base that on the net current reaching the battery. Now, your resting voltage of your lead acid battery, it's probably going to be about 12.5, 12.7 if it's pretty new. So if you're maintaining that battery at 14.4, let's say, for example, that's always going to take some power to make that happen, right? You're not down here, you're up here. So it's always going to take some amount of power to keep that battery at that higher voltage. And that's okay, right? But at some point, that amount of power becomes redundant. You're just wasting your time because you're just providing power to keep it at that higher voltage. And so the other way to make that transition happen is to base it on the net current reaching the battery. In order to do that, you install a current shunt, and I have one up here. You install a current shunt between your battery, bank, and everything else. So between all loads, charge sources, your ground, that all connects to one side of the shunt. We term it the load side, but that's just a term. And then just your batteries are connected to the battery side of the shunt. So a lot of times when I do product support, I'll say, okay, put your finger on every negative post of every battery. The only thing touching that finger should be either another battery or the shunt, with the only caveat being if you had a battery temperature sensor. Different batteries like different transition set points. Lifeline specifies 0.5 amps per 100 amp hours of capacity. Our factory default is about 1.5 amps, which is more suitable for like lead acid batteries. So that's a much better way to do it. That way, when your controller wakes up, it goes, woohoo, it goes to the absorption voltage. If your batteries are fully charged, it will then say, oh, we're full, it's only taking 0.5 amp to maintain this voltage, boom, I'm in flow. If your batteries were heavily discharged, or if you had a lot of loads going on while you're in the absorption phase, it'll hold that voltage longer as needed. So when it does eventually transition to the float mode, then your batteries are definitely fully charged, and that increases longevity. Now, at the absorption voltage, it's one of these things. It's kind of like you pick the worst of the two evils. In a lead acid battery, they've got this secret sauce or paste on all the lead plates. Now, this is just keeps the lead plates healthy, but this secret sauce degrades whenever your batteries are at this higher voltage, right? So you don't want to hold that voltage unnecessarily long. That's why you don't keep a battery at 14.4 forever. It's because you're degrading this special sauce, this secret chemistry, which varies between manufacturers. That's like the Kentucky Fried Chicken secret recipe kind of thing going on. But you need to get to that higher voltage long enough in order to keep your batteries from being sulfated. So you kind of want to play this game. So you are going to increase your battery's longevity by basing that transition between absorption and float mode. But a lot of times people don't have the shunt installed, and they just have, for example, our 3000i. A lot of times what I'll recommend is 2 different charge profiles on your 3000i or a charge controller. One for storage mode when it's, you're putting it up for the winter or the summer, depending on where you live. And then one for when you're actively cycling the battery. Any questions so far? Awesome. Now, we talked a little bit like equalizing the batteries, right? Well, let's back up. Storage charge profile real quick. I'm sure you guys have heard the expression when your battery is in storage, you've probably heard like every now and then you should exercise your batteries. You might have heard that expression, you should exercise your batteries every now and then. Well, that's not necessarily true. What they're really saying is you want to trick your charge controller, depending on what controller you have, right, to get to that higher absorption voltage on occasion. Now, it used to be, or used to think, that holding the float voltage, let's say 13.3, let's say you put your van in, you just have a little charger and it holds 13.3 volts indefinitely. When I come back, my battery is going to be perfect? Not necessarily, right? You do want to get it every now and then to that 14.4, the absorption voltage, in order to make sure those plates stay clean. You don't have to get there every day, but you do want to get there on occasion. So when they say exercise your batteries, they're more saying, oh, trick your charge controller to get back up to the absorption phase on occasion. So a lot of times if people have a standalone charge controller without the shunt, then I would say, okay, tell you what, program your controller so that it maintains the float voltage forever, but then utilize our automatic equalization feature and adjust your equalization voltage. So every 2 or 3 weeks, we maintain the absorption voltage for a couple hours, right? So the best of both worlds. Programming our controllers is all digital. It's all very nice. You push some buttons. Of course, we've got videos on our website describing how to do it. Of course, I'm always available as well. Now, if you had the shunt installed, that's a moot point because every day your controller is going to get to the absorption voltage, although it's only going to hang out there for a couple seconds, right? But the fact that it got there for even 2 minutes a day, make sure that sulfation stays off. So you don't really need to program a storage charge profile if you have a current shunt installed. I'm only talking about standalone charge controllers. Talking about charge profiles, all of our controllers can also equalize batteries. Now, you can program it to happen automatically for whatever duration, time period you want, or you can have it happen manually. Normally, unless you're Johnny on the spot, I like to check my batteries the first of every month on the first, like clockwork. I normally recommend people do manual equalizations just because it's important to, check your fluid levels if you have flooded batteries prior to equalizing them. Because when you equalize a battery, depending on the type of battery, the voltage might be anywhere between 15.4 to Trojan 16.2. Woo! I even called Trojan. I'm like, really? They're like, really? I'm like, okay. You guys know what you're doing. But like at that voltage, your batteries are gurgling quite a bit. And that's not a bad thing. Not only is that higher voltage cleaning off the sulfation of your plates, but also that gurgling stirs the acid and water mix within your batteries. In your batteries, the acid is heavier than the water. And so if you let them go for a long time without gurgling, what can happen is called stratification of your plates. So that coral reef analogy kind of grows on the bottom of the plates instead of the whole plate, and now you have less surface area, so it doesn't work as well. So you can do automatic equalizations, you can do manual equalizations, whatever floats your boat, right? That's an easy peasy, plug and play kind of situation. Any questions on equalizing? How long do you normally equalize a battery? Well, I mean, you can equalize a battery for 8 hours, 2 days, 3 days a week in a row. The problem is, as you're at that higher voltage, you are getting rid of some of that secret sauce. And so you're playing this game again. As a rule of thumb, an industry standard, if you're a full-time boondocker and you're cycling your batteries every day, they say about 2 hours every month is a good time period. Now, if you're in storage mode and you're a weekend warrior, I would do it probably quarterly for a couple hours. But, even Bill will tell you, people sometimes come in here and they have one bad battery and they have a whole set. And so and they buy a whole new set of batteries. He'll take them back there, equalize them at 15.8 for like 2 days, keeping the water levels up. Then you can sell them at pretty good used batteries, right? So you can recover batteries by equalizing them. But so it's not too long because you don't want to ruin that secret sauce. But if your batteries lifespan is diminishing, you might have to take the lesser of the two evils. Now, okay, yeah. Yeah. He normally does one. Now, 1 battery, 4 batteries, 10 batteries, assuming you install them correctly. Like when you install batteries, let's say you have four 12-volt batteries to keep things simple. You want your positive on battery 1 and your negative on battery 4, right? So the voltage meets in the middle. You don't want to walk down the ladder. You don't want everything connected on this battery and bang, 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 bang. But if your battery voltage is up, your battery voltage is up, your series voltage. And so 1 or 10, it really doesn't matter. You don't have to individually, as long as you're... Right. Well, I don't know. I've seen he's got a system out there with a monster charger. He can hook up individual batteries. You know what I mean? He's not going to string them together just to, save the one charge. Talking a little bit, the gentleman before us talked a little about like equalizing AGM batteries, right? Now, the biggest problem with, like you said, the biggest problem with equalizing AGM battery is you're not getting that electrolyte, that water back. If it turns into steam, it's not going back in it, right? Now, Lifeline does say, you can do 15.5 for up to 6 hours. But they specify that, you normally don't have to do it unless your batteries were severely discharged or unless they hadn't been fully charged in a long, long time, right? Normally, if somebody does want to equalize an AGM, I'd recommend a very short equalization period for multiple days in a row versus one long period where that heat can accumulate inside your battery and all of a sudden you lose it. So if you want 6 hours, I want 1 hour a day for 6 days. I don't want 6 hours in a row. I've had other people say that with the Lifelines, the Concord batteries, that they say, a half an hour equalization cycle every 2 weeks. He has customers that claim to have done that and their batteries are 10 years old, they're still rocking and rolling. Now, one way you can tell the life of your battery, my preferred way of telling how healthy your battery is, of course, you could take your hydrometer and you could check the acid, water, levels in your battery. Another nice way to do it, especially for sealed batteries, is once your battery is fully charged, look at its average voltage while discharging. Now, when you get a brand new battery, it's going to be like, okay, my battery is, when it's discharging that first 30% with a modest load, 5 amps or whatever, I'm not talking about running a microwave, my brand new battery is averaging like 12.7. 12.6, while discharging, that first 30%, new battery. Take that battery, fast forward 6 years, or unhealthy battery's like getting toward the end of its days. Now its average voltage is like 12.3 volts, right? It's coming down. And then I equalized it for, the day. Now my average voltage is 12.5 again during that first 30%. So your average voltage while discharging is a really good indicator of the overall health of your batteries. I've camped out here with you guys, after the shows and whatever. And the guy's like, man, I'm at 12.2 all day. I don't care. All night I'm at 12.2, but it's hanging out there. It's staying at 12.2. It's not plummeting. And so his batteries are on the very tail end of their lifespan, but, he's still happy with it. If you're happy and your system's running, you don't necessarily have to run out and, like change your batteries and this and that. But at the same time, if you wake up and your batteries are under 12 volts or like maybe under 11.8 volts, yeah, you're getting about that time, That horse might go out to the pastures in the big picture. Like you talked about, lithium batteries don't really suffer this as much. Their average voltage is really, really stable. But if you do go with a lithium battery, I would recommend, let me back up. When you use our current shunt, the IPN Pro Remote also gives you state of charge information based on the current coming in and out of your battery. So it'll tell your battery's approximate state of charge based on that current in and out. So now instead of saying, oh, my battery's at 12.3 volts, I think they're pretty charged, it's more like, okay, out of 400 amp hours, I've got 250 left, right? And I'm at X% state of charge. So you have much more idea of your state of charge. Now this becomes a lot more important with lithium batteries because if you look at the voltage of a lithium battery, it drops like a rock, it's really straight, and it drops like a rock. They call it the hockey stick. Like two inverted hockey sticks. So a lithium battery isn't going to give you much warning before it's dead. It's like, I'm at 12.8, I'm at 12.8, I'm at 12.8, I'm off. It doesn't, unlike a lead acid battery, you can't say, oh, I'm down to 12.2, I should run the generator. It's really not going to give you any heads up, a little bit of heads up.
Can that be modified with BMS?
No, that's just lithiums in general. Lithiums in general have a very, can you have the BMS modify that drop off?
Compared to an electric drill.
Exactly, like an electric drill. If you had an electric drill, it's going to run great, and then it's done.
Thank you, Bill. Because my 18-year-old lithium-ion electric drill
Yeah.
still performs 100%. But it does that run, dead. Now, I just bought an e-bike,
Well, you have the two different lithium chemistries, right? In general, they're categorized in their charge and discharge. They have two different categories. You've got your lithium iron phosphate, or LiFeO4, right? And that's what all these deep cycle application batteries are going to be. Any large amp hour battery is going to be a lithium iron phosphate, a LiFeO4. On the other side of the boat, you've got your what they're termed Li-ion, right? Lithium cobalt, lithium manganese. And those basically, they use the Sanyo 18650 cells. And then there's a different, more exotic chemistries about them, but their discharge curve is more analog. It's more like digga 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 digga. Not completely, it's more like, not, but it's,
Can I get that great battery profile in my keyboard?
get a lithium iron phosphate battery, like Biano batteries. They make some really nice, different, like 48 volt nominal, 36 volt nominal, 10 amp hour batteries, right? They're pretty uncommon in the e-bikes. Those are all like the 18650 cells, and they vary between like a 13S and a 14S configuration.
So why are they putting together batteries in e-bikes?
It's cheaper, and it's cheaper, But also the size of the cells. The 18650 cell looks like a double A, right? So you can make these packs, really much smaller, whereas, your LiFeO4 is going to be more of a brick or a wafer. So they do make different size, lithium, the wafer LiFeO4s or like the, the flooded types. But it's pretty much a cost thing, is what it really comes down to.
What I don't understand is why they're putting a good battery into a drill.
Well, it's not a bad, well, and the drill is Li-ion. That's a lithium polymer, or an 18650. Your drill's the same way. It's just your drill's BMS might just have a cutoff. That's normally the way it works. Like the battery management system in a lithium battery, the major dangers of lithium, not dangers, like if you just had a cell with nothing on it, right? So you're like not talking about a complete unit, but you want to just talk about a raw cell. The major dangers of lithium batteries, either Li-ion, manganese, cobalt, or iron phosphate, is you don't want to overcharge them, right? You can't bring the voltage beyond a certain point. And if you discharge them beyond a certain point, you got to charge them really slowly, or else everything goes kaboom. So that's why all the BMSs will make sure they don't get discharged beyond a certain point. After it's cut off voltage, bang. And the same thing on the charge voltage. If you try to overcharge one of these batteries, that's going to cut it off as a safety factor. And then the BMS also plays more important roles, like they monitor the temperature of each cell, because you can have something called Coulombic runaway. So if a cell goes bad, its temperature is going to go up and its voltage is going to spike much faster than all its buddies. And then they also talk about like balancing a lithium battery. Prior to this job, I built like 1,000 batteries for the earthquake sensors up in Alaska. Owner of the same company. Genasun used to make some really high-tech Genasun, lithium batteries. Kind of steered away from that market, focusing more on charge controllers. But I made a bunch, and in the process, we tested all these. So we discharge them, and then we charge them back up. And a lot of them would be like all 4 cells are like nice, and every now and then these would be nice, and this guy goes whack. Now if this guy's way up here and these are here, your series voltage is going to be the same, right? You're still going to be at 14.2, 14.4 volts, but your cells are hugely imbalanced. So a BMS, when you maintain that top voltage, they do what's called top balancing. So it's going to drain this cell, charge this cell. Obviously, if your cells are completely askew, that's not ideal. But in general, unlike a lead-acid battery, those voltages of those cells aren't going to hit the top at exactly the same point. How long should I keep a balancing charge in my lithium battery? Different manufacturers say different things. I've heard as little as 12 minutes, and Battleborn recommends 1 hour per battery. Don't quite understand that, but that's, I'm not going to argue with Battleborn.
Is it possible for the BMS to isolate and disengage an individual cell?
During the balancing period, that's kind of what they do.
So let's say it has catastrophic failure with one cell. Can it utilize the rest of the 99% of the battery?
I'm just going to reiterate because okay, so he's asking like, if you had a lithium battery and one cell, takes a dump on you, goes down the way, can it still operate? And unfortunately, not really, because each cell contributes about 3.2 volts per nominal. That's their nominal voltage, 3.2 volts per cell. And generally speaking, a lithium iron phosphate is going to have, it'd be a 4S configuration, 4 cells. So if you lose one cell, you only got 9.8 volts or 9.6 volts instead of 12.8, and your system's not going to work. But like Relion and every other lithium battery I've heard of that is somewhat of a brand name, I've never heard bad things about their customer support. Like you mentioned, you can ship lithium batteries. You can use UPS or whatever. You know, they can help you out with that. I've shipped them all day long. It's really no big deal. Um, no big deal.
That's our dustless saw.
Any questions on that so far? Okay, great. Another thing I always highly recommend is a battery temperature sensor, right? Now batteries, lead acid batteries, want to be charged at slightly higher or slightly lower voltages depending how hot or cold they are, right? The hotter the battery, the lower the voltage they want, and vice versa. Now a battery temperature sensor doesn't cost much, $30-ish, right? But once you install it, it's plug and play. You forget about it. And that's one of those things that's going to greatly contribute to your batteries lasting longer, right? Your battery's going to last a whole lot longer with a little bit of an investment with a battery temperature sensor.
It also changes the charging rate. What does it do on a lithium battery?
On a lithium battery, you don't want a temperature sensor, right? You don't. Now, lithium batteries, you don't provide temperature compensation, right? The only caveat on lithium batteries is you never want to charge them when they're below freezing. When they're 0 degrees or below, you never want to charge them. That's a lithium iron phosphate chemistry thing.
But you can use it.
It depends on the BMS. You would hope the BMS wouldn't allow it, right? I'm not going to speak for all BMSs. Not all BMSs are created equally, you know? Now, if you're in an environment that your batteries are getting super cold, they do make battery blankets, which is the way a lot of people will do it. So what they do is they have the little blanket, and it says, okay, if my battery's under 0 C, pour a little current in the battery and get it above before I start charging. You also don't want to charge a frozen lead acid battery, right? But at the same time, the freezing point of a lead acid battery, if it's fully charged, is much higher, or much lower, I should say, because there's more acid than water. So if you have a fully discharged lead acid battery, it's going to try to freeze rock solid, you know, just below 0 C, whereas if you have a fully charged lead acid battery, not so much. So I don't know, like if you guys, I mean, I'm sure a lot of people have parked their car in the winter in like Minnesota or something, right? And it got below freezing, but nobody's battery, generally speaking, exploded on them or frozen up. That's because, generally speaking, you know, a car battery, a starting battery, is going to be maintained fully charged. And so it doesn't suffer that below freezing, you know, set point. So I do really recommend, now you can on our controller, if you have a battery temperature sensor and you go lithium, you can just set the temperature compensation factor to 0. You don't have to throw away your battery temperature sensor. You can still keep it on there and see what your battery temperature sensor is. But we want to change that compensation factor down to 0 so that it doesn't actually affect the charge profile of the battery.
What were the batteries that Boeing was using that smoked and caught on fire or what it was?
I mean, I don't know. You know, it's not a lithium iron phosphate. It's probably the lithium cobalt, lithium magnesium, lithium polymer technology. Because you can put manganese. Because you could take one of the lithium LiFeO4 cells, throw it in a campfire, not going to catch on fire, right? It's just a really safe technology. So that's one of those things. That's why they're allowed to ship and everything like that. But all the e-bikes and those little scooter fires and stuff like that, those are the 18650 cells. And that's normally because if you put together these packs, you know, there's a lot more batteries in it. Unlike it's a 4S configuration, when you get these larger packs like a 48 volt nominal pack is going to have 13 to 14 cells in it. And then they'll have what's called like a 1S 2P. So now you have 1S, 13 cells, 2P, 2 of those banks in parallel. So now you've got like 26, 27 different items that can go wrong. Also, that's a total of like 34 different connections that can go wrong on either side of it. But they are, you know, less expensive, and they just tend to be more popular in the e-bikes and the scooters just because of a price point situation. We do a lot of stuff with the Genasun in particular, because one of the Genasun products, we make a boost type charge controller. So before we talked about, you know, we're bucking down that energy from a solar panel to lower battery voltage. One of the Genasun controllers can actually boost voltage. So it's super popular with the electric bike industry, because now it can take your 12 volt panel, it can boost that voltage and charge 48 volt nominal or 52 volt nominal. You know, multi-stage profile for lead acid, you know, or lithium, or you can of course, you know, do, you know, LiFeO4, just different charge profiles, you know, happen to it. And I don't want to dive too much in like the charge profile. I would say one thing, a little known fact about the LiFo 4s, or the lithium iron, I mean the Li-iron, the 18650 cells, the cobalt manganese chemistries, is there's a direct relationship between the voltage charge and their lifespan and the percentage charge. You know, if you talk about the basic 18650 cell, and I don't want to go too far in it because that's really years, and I'd love to talk to you more about afterwards. But if you charge them 100%, 4.2 volts per cell, they last 300 to 500 charge cycles. You charge it to 85%, 4.05 volts, 800 to 1200 cycles, right? You charge it to 60%, 3.92, it's more like 1500 to 2000 cycles. Now there's some more exotic chemistries on it, and they have increased that cycle life to a degree from the basic 18650 to the super sexy one. So I'm not, but the principles still apply. So I'll cover that a little because that's not really an RV question. You know what I mean? Nobody's going to have, you know, manganese, cobalt batteries in their rig because they can get that runaway voltage and they can become dangerous. Any questions so far?
Quickly on this, but you don't want to you can't charge a lithium ion below.
When the battery is below freezing.
But conversely, you could discharge.
You can discharge it, yeah.
Because it'll just warm up a little bit. It'll just
They don't really generate heat while discharging, unlike a lead acid battery. So, I mean, if you're going to be in an environment like that, just a battery blanket. You know, they sell different wattages battery blankets and stuff like that, but that is one thing you have to take into consideration.
But the discharge phase doesn't hurt it.
Doesn't hurt it.
And as long as you don't try to charge it again.
Right. For example, the batteries we had up in Alaska, you know, they had all these batteries because they had to last a long, you know, Alaskan winter. You know, and so they would charge them up before the winter, and they stick them out there, and they'd slowly. These were like earthquake sensors, and they would slowly discharge throughout the entire time, and they're in well below freezing, and it doesn't hurt them at all. It's just recombining those chemicals is what it comes down to. Any questions so far? Okay. Other things our controllers have, just as optional features, they have most of our controllers will have a 2 amp auxiliary battery maintainer. So when you have extra solar power available, it can maintain your starting battery independent of your main battery bank. You got a question, sir? Okay, yeah, no, that's all right. So, oh, okay.
Can you repeat that again?
Okay. Many of our controllers have a 2 amp auxiliary battery maintainer, right? So whenever your controller is in absorption or float mode, indicating there's excess PV input available, it can send up to 2 amps to your starting battery independent of your main battery bank. And that way, if you're in storage mode, or at other situations where people had they play their radio off their car receiver, we know they're sitting out there, and every time they go in to start the car, it ends up being dead, because even though their solar is charging their main battery bank, their starting battery is running their radio. But it'll keep it topped off and fully maintained. And that's really as simple as just connecting a wire from here to here, right, with a 20 amp fuse in the middle, like a 14 gauge wire to keep the voltage drop to a minimum. Another feature our controllers have, which aren't as popular in the RV community, but they're there, our controllers have what's called a 20 amp low voltage disconnect, or an LVD, which would allow up to 20 amps to be available unless your battery voltage got too low, then it disconnect that current, and then once your batteries got charged up again. Now we can increase that to 70 amps or 150, for small amounts of time. We do sell our CBM, a current booster module, which basically acts like a solid state switch. It's a big relay. So we can increase that capability. I've had people, for example, run fans in their rig and set the voltages so, because everything's programmable. So a lot of times I'll have people, have like fans in their rig in storage mode, and they'll say, okay, when the battery is above, 13 and a half, turn on the fans, and when it's below 13, turn off. What that means is those fans are only going to be on when your solar power is active and charging. And now if you covered the van or the panels got snowed over, your resting voltage is going to be below 13, and all of a sudden, your output's not available. That output, that 20 amp LVD output, also can be programmed for dusk to dawn lighting. So we have the capability of saying, okay, when the sun sets, turn on this load for X number of hours. And when the sun rises, turn off the load, or before it rises, have it available, or have it available the whole time. Now, mostly this trick is done with like mariners. When mariners are out on the hook, meaning they're out tied to a buoy or that anchor, and they're on shore, they can have that feature turn on the lights, have that little LED light. They'll have it turn on the lights after the sun sets, mimicking somebody being on board, and then turn on when off. You know, and that's another thing. A trick could apply to a camper. You could have a little LED light turn on the camper for a couple hours after, when you're in town, and turn off. And all this is programmable. It's not as popular with the RV community, but it's out there. If you ever had like a security light situation, you wanted to have a light come on outside your garage, no problem. And that output still has that LVD control. So if your loads, your battery voltage drops too low, it turns it off. And all the voltages on-off wires are completely programmable. So you can toy with it any way you want. Yes, ma'am.
If you have AGMs in a solar system, and you want to get rid of the AGMs and buy the ion,
Yeah.
do you have to change the solar controller?
You don't have to change the controller, but you got to change the charge profile. So, I mean, the most important, like the charge voltage on a lithium battery is between 14.2 to 14.6, right? Now, which voltage I would recommend really depends on a little bit on the wiring. Like if any lithium battery, you get to 14.2, it's going to be 98-ish% charged, and that's fine. Now, if your controller is way over here and your battery's way over there, or in any situation of charging, you're going to have a voltage drop due to the resistance. And so I want the battery voltage to be 14.2. Now, when you charge a lithium battery, unlike a lead acid battery, when the battery voltage gets to 14.2, minus balancing, it's charged, right? So the amount of current needed to maintain that 14.2 on that battery is going to drop like a rock, just fall right off the cliff. The amount of current needed to maintain that voltage, unlike a lead acid battery where like you're putting out 20 amps, 20 amps, 20 amps, you get absorption to 19 amps, 19 amps, 18, 18, you're wrapping up, depending on your depth of discharge, that last 20% state of charge. You're wrapping that up. So that can take a little time. But like a lithium battery, talking about like the volt drop and the balancing time, lithium battery like 20 amps, 20 amps, 20 amps, 14.2, half an amp, And when that charge current drops off like a rock, so does the resistance. And now all of a sudden your battery voltages will become a lot more in balance. But it might be like 14.4 is ideal, so you have 14.2 at the battery, might be 14.3, 14.2 at the battery, might be 14.2, 14.2. Usually when one second, but normally when I recommend the charge voltage for a lithium battery, I'd say 14.4 is a good number, right? And then you can play with it. You can say, as soon as I get to absorption phase, you can check the voltage on your battery. If it's 14.4, 14.4, maybe knock it down a little bit, maybe, because you really want to increase the lifespan of your batteries, your lithium batteries. And so, I'd rather sacrifice a few percent state of charge and increase the longevity than stress out the cells, and maybe that's where you get in the fine line, like 14.2 at the battery versus 14.6 at the battery. If you could have it 14.2, your lithium iron phosphate is going to last a lot longer. More importantly, the float voltage is the big difference between a lithium battery and a lead acid battery. Now, with a lithium battery, you don't traditionally float it, right? A lead acid battery, you're always providing some power to keep it at 13.2, 13.4 to maintain it above its resting voltage. Now, you don't traditionally float a lithium battery. You don't want to actually have to provide current to maintain the lithium battery at its voltage above its resting voltage. But a lithium battery's initial resting voltage is like 13.6, 13.6 and a half. After 2 weeks, it'll settle down to like 13.4, 13.4 and a half. So you do need to have a float voltage because you have to pick some point to take care of your loads prior to the sun setting. It doesn't do any good to charge your battery just to discharge it until the sun sets, right? So you charge the battery, and then you pick a float voltage, which is just underneath the resting voltage of the lithium battery, so that it can, you're not providing current to maintain that voltage, but at the same time, you're supplementing all your usage in your rig until the sun sets. So yes, you don't float a lithium, but you do have to pick a set point in order not to discharge your battery once you charge it, and so you have full power going into the night. Yes, sir.
Okay, so let's take a hypothetical case.
Okay.
You got a nice motor home, and it has lead acid batteries that came with it. And you want to and you've got a group of them. So you got 2 or 3. Okay, and you want to transition into lithium ion, but you don't want to throw those nice lead acid batteries that are working fine. So if you have a solar setup and
Well, the major, what he's asking, I'm just reiterating for, what he's asking is, can I combine a lead acid bank with a lithium bank? Basically, is what you're asking. In general, even with their two different charge controllers, two different charge profiles, can you combine them? In the end, you would need an AB switch, like a marine AB switch. And the reason for that is the resting voltage of a lithium battery is like 13.6, 13.4. Resting voltage of a lead acid battery, 12.7.
Right, so it's going to be parasitic load. Let's just say,
One's gonna,
let's just say you
yeah.
use one controller, and what will happen is that the lead acid battery is going to draw down. Once the BMS shuts off the lithium battery, once it shuts it off, even though you're putting charge to it.
Well, it's not. The only time a BMS is going to shut off your battery is if it's over voltage or under voltage.
But if it's, well, what's you said? But you said the BMS will shut off the lithium ion itself when it reaches.
If it gets a BMS on a lithium battery,
Right.
it's designed for over voltage protection
Right.
or under voltage protection.
I thought you said it cut off.
What it does is once you reach that, once a lithium battery achieves its charge voltage, 14.2 to 14.6, then it begins to balance the cells. I mean, it's going to try to discharge this cell to charge this. Now, if you're still pouring current into that battery, the voltage is still going to rise. But you need, it doesn't stop the input, right? It doesn't stop the input to the battery unless its voltage gets too high, like 14.8, right? Now, you can do what you're saying, and you can even there's a lot of translation. Like, for example, a lead acid battery, if you set it to 14.4, 13.6, that's not a horrible charge profile for a lead acid battery. It might be a little high on the float, but it's not horrible. But the biggest problem is once the sun sets, right, and you're done charging, now you've got a nominal voltage of 12.8 and a nominal of resting voltage of this. Now your higher resting voltage of a lithium battery is going to charge your lead acid battery.
It's going to be discharged into the
Lead acid, correct.
Do you have a 3000i with you by chance?
No, I don't.
God, I'm out.
Mm.
My point is, if you had the two controllers, you had a battery bank one, battery bank two, then you don't really have to throw away perfectly good lead acid batteries.
Yeah, you kind of have an AB switch. Now, one thing on the AB switch, one thing I'm going to throw out there is, and this blows up more controllers and electronics than you would think of, is now everybody knows well, if you don't know what a charge relay is, right? Now, if you're running your rig, and your rig is powering your main battery bank while your engine's running, so your alternator is charging your main battery bank. That's what a charge relay does, right? And that's fine because your average alternator, even with a lithium battery, your average alternator is going to put about 14.2, 14.4 volts. So it's not going to overcharge your lithium. Now the downside of that is if you're going on an 18-hour ride, well, for 18 hours, your lithium battery is going to be held at that 14.4, and generally speaking, that's not the healthiest thing to do with a lithium battery. You don't, just like you don't want to maintain a lead acid battery at the absorption voltage indefinitely, same thing applies for lithium. They do make several smart chargers and smart relays out there, but more importantly, if you go with lithium, I'd make sure you have not a dual sensing ACR, automatic charge relay. Because what can happen is, like for example, the Blue Sea, not Blue Sky, Blue Sea ACR dash, the automatic, the dual sensing. What it does, it says, okay, when the starting battery is above 13 volts, share the power with the main battery. When the main battery is above 13 volts, share the power with your starting battery. And that's fine for lead acid because now, okay, when I have solar in my main battery bank, it'll keep my starting battery topped off, right? But at the same time, if you have lithium with your resting voltage of 13.4, now it's going to discharge your lithium battery trying to start your starting battery. So you can have a charge relay, but you want to make sure what kind you have. You don't want a dual sensing charge relay. You just want it so it operates when it's running.
As an example, we're out here in Arizona, that's all well and good, you got sun all day. But at night, all you'd actually have to do is you said about flip switch to separate
Right, yeah, you could do it manually. I mean, you could do it manually. You could also not.
You really don't need to have two different charge controllers.
Well, I mean, you don't need to have two different charge controllers. You're quite correct. In your situation, you could isolate it.
Shut the lithium off.
Yeah, and do one or the other when you're discharging. One thing I would mention, the reason I brought the AB switch up along with the charge relay, and it really not as applicable here, but I just want to put it out there, is a lot of people, if you have a generator or you have with an AB switch or something like that, right? On a starting battery, a lot of marine applications blow up their electronics because they have their starting battery and their main battery bank, and they have the switch that goes starting battery, main battery. So they start their motor, and then they go, okay, my motor battery started. I'm gonna switch it to the main battery bank, and then everything explodes. The problem is an alternator, the regulator, it always has to see a voltage to maintain its output, and that microsecond between A and B, the regulator goes unregulated, and it just goes like 120 volts, you know, boom, all your electronics explode. Yeah, I mean, yeah, you can buy alternators with the field interrupt. Like you can make it so it shuts down for that microsecond. But that really isn't as applicable here because everybody here has a starting battery and a main battery bank. But you know, if you had just if they were one and the same, and you're trying to do your trick, make sure you have a field interrupt wire on there. But that's kind of more of a marine thing. That's not really a.
It was a marine thing. we were in that mode.
Yeah, totally. Any questions so far? Yeah.
I've got four 25 amp hour golf cart batteries, 40 amp charge controller. What size diffuse should I be using for the battery?
Generally speaking, you want to overrate it about 10 amps. So if you have a 40 amp charge controller, or 40 amp max output charge controller, you want about a 50 amp fuse. You know. Now it's more important when you get to like DC breakers. Like in general, rigid fuses don't blow at 40. If you have a 40 amp fuse, it's not going to blow at 41, right? But DC breakers, if you have a 40 amp DC breaker and you're running at 40, it can get hot and all of a sudden continually trip on you. Just like any residential panel. Like once you heard it, you're like, darn it, you know, I need a shorter extension cord or a thicker one because you're drawing too much power out of it. So you definitely want to oversize it at about 10 amps. Really, the fuses are there for short circuit protection, right? Now, you could put a 100 amp fuse, right, on your controller. Your battery's got hundreds and hundreds and hundreds of amps available. And if you, for example, let's say, God forbid, you had water damage on your controller or one of your wires crossed out, that short's going to go to the battery. So that the fuse rate and the fuse size isn't super important. It's always ideal, you know, we don't want to overdo it. But if you have a 60 amp fuse that calls for 40, who cares, right? Because I'm going to have 300 if something goes wrong. A lot of people also talk about the fusing. Do I need a fuse on my PV input? Do I need a fuse on the input side? Now, of course, I'm not going to get in way of any electrical, you know, suggestions, or everybody's willing to do whatever you want. If you've got a really nice fuse, I'll talk about styles of fuses in a little bit, then it's not going to hurt. But in general, it's not really necessary. That's because it's not very well known, but you can take a solar panel, face it at the sun, tie its output wires together, leave it for a year. Panel don't care, right? Doesn't hurt the panel. You know, if you have a PV input connected to your charge controller and you short those wires, even if there's a fuse, your charge controller's dying, right? It can't protect. The fuse doesn't react fast enough to protect the charge controller if you short the PV input while the controller is energized.
We fuse both sides.
Yeah, and it doesn't hurt to have a fuse, right? But it's one of those, and like lightning can make a big difference. Like if you get hit by lightning, that fuse is gonna do a lot of good for you. You know what I mean?
Well, another reason we do it is because a lot of people, they don't want their solar system to work so they can undo the solar system. But you never want to disconnect the battery from the solar system because it's going to burn up his unit.
Yeah, he makes a really good point.
I have one fuse and one not.
Yeah, that's a really good point. So, our charge controller, any charge source, you don't want to have a charge source actively pouring current into the battery and all of a sudden take the battery out of the loop. That's what's called a load dump.
That's when
right?
you're changing your batteries out. For 20 minutes or so, it doesn't really matter that much.
Well, it's just the instant you do it. It doesn't matter. Like our charge controller, well, on the 3000i, one setting flips, right? And it's just one of those weird things, just on the 3000i. But leaving that aside, in general, think of it like you have a fire hose, and it's pouring water into your battery, right? It's pouring water. All of a sudden, you take the battery out of the loop. It's like putting your hand in front of that hose. Now, I don't care how fast you are on the nozzle. You know, that energy is traveling about the 10th the speed of light, right? So I don't care how fast you try to throttle back, you're going to get splashed. And that splash ends up being what it's called a load dump. It's a voltage spike. Now, it reacts super fast, but having any load dump like that is not healthy on electronics.
Would that not be the same as your battery bank fuse blowing?
It is true. I mean, it's not going to, like, people mess up on this all the time. You know what I mean? I've never had it directly break one of our controllers, but it's a no-no. On one of our controllers, if you do that, sometimes that auxiliary load output setting will switch. You got to go back in there and switch it back. So I've never had it directly break a controller, but it's not advised to do it, for sure. That goes for any charge source. Potentially, and not just our controller. Like, yeah, your converter, your inverter, like anything that's putting power into it. Even a Black & Decker charger, it's not a good thing, you know. Maybe not Black & Decker. I mean, they don't make very good stuff. You know, I'm not, you know, most Black & Decker chargers, a lot of, you know, your off-the-wall battery chargers don't have a multi-stage charge profile. Generally speaking, they're going to bring your batteries up to 14-ish, and then once the amount of current needed to maintain the voltage drops below whatever their set point is consider your battery fully charged.
Also, Black & Decker does not like modified sine wave inverters. Burns them up.
Is it possible to set up auxiliary battery
I mean, DeWalt.
with an isolator so they cannot accept charge but can provide 12-volt power to the charge controller to prevent that from happening?
Not sure I completely. You're saying that, yeah, right.
Let's say I want to put a small 12-volt battery that would supply power to the charge controller in the event that that fuse on the battery bank blows.
I mean,
Possible to have
electrically, if you had a bunch of blocking diodes, then yes, that would allow current to go one way and not the other. Although I haven't heard anything commercially available, because you need a ton. You'd have to stack them up because the amount of current each one can take. So blocking diodes, that's exactly what they do. They allow power to go one way and not the other way. That's, for example, on a solar system, they call them anti-reverse diodes.
how much power does the charge controller require?
So bypass is a little different than the blocking. What's that?
How much power does the charge controller require to operate?
Our charge controller requires at least 9 volts to be in standby mode.
9 volts, but how many amps?
I'd have to look it up on the milliamps. It varies per charge controller. Generally speaking, you're talking, its self-consumption is about a half an amp hour a day while actively charging and its whole life cycle. So about a half amp hour a day. So if you do cover your motorhome after the season, you know, you do want to make sure that our controller is connected to the same circuit as your battery disconnect switch. Because any parasitic draw can drag you down, and you want to completely isolate your batteries if possible. You know, if you have, you know, the LVD and like any install in any motorhome, I'd always recommend installing a low voltage disconnect, a big one. They're not very expensive, you know, less than 200 bucks, 100 and some odd, 80 bucks, depends on how many current you want to draw. But I've had a lot of horror stories happen where people say, man, Brian, you know, you know, I leave my boat in the Bahamas for 6 months out of the year. I always keep the solar running, and that keeps the fans and, you know, the bilge pump going. But then this year, after 12 years, I come back and my battery is completely dead because the controller died, right? And now this is like, nothing electronic lasts forever. I'm like, well, it did last well over a decade. That's not a bad run for something operating. I don't know how old your car is, but that's not a bad deal. Now, and that's kind of like the guy that has all his information on his computer and it's not backed up, and all of a sudden his hard drive stops spinning. It's like, oh my God, I lost everything, you know? You got to have a backup plan. And so a low voltage disconnect, basically, you just wire it in series between your positive battery bank and everything else, and it says, well, keep, you know, everything working, but if the battery voltage gets below, you know, 11.5, 11.8, whatever you set it to, shut it down, isolate these batteries. That's a backup plan. So, of course, I mean, batteries self-discharge at different rates. Lead-acid flooded battery will discharge at about 12% a month. A sealed AGM battery, about 2 or 3% a month. A lithium battery, maybe 1%, probably less, by like a 0.5% a month, maybe less, on self-discharge. So you want to, it's good to have your solar in there to keep your batteries fully charged, just to keep them topped off. Not to mention, like we talked about, you know, getting that absorption voltage every now and then. But you've got your rig out in the middle of nowhere, you've got your solar set up, but God forbid something happens, hits your panels, whatever goes wrong, and everything, you know, what's your backup plan? You know, what's going to save your $2,000 or more of batteries if something goes wrong? So I do recommend having a low voltage disconnect in any system.
Long-term storage does it. Should you leave your lithium-ion phosphate battery fully charged when you're going to storage, or should it be partially not?
The book says you want to leave it partially discharged. Now, and I've heard it from like It varied between, now legally when they ship it, it's got to be 30% state of charge. That's the legal UN 3480 or whatever it is.
E-bikes,
Right,
by the way.
right,
It's a little teeny bit.
right. And that's the same thing, like keeping them fully charged puts a little stress on the cells. But no, as a rule of thumb, I'd say about 30% discharged, 70% charged when storing a lithium battery. Of course, your battery manufacturer. Now, again, if you don't have a battery monitor, how much is that? I don't know. It's hard to say. You could just run stuff for half the day, but you can leave that half charged. I've got a 30 one of the batteries we made with earthquake sensors, and that was like 5 years ago. It's still sitting in my closet, 30% charged. When I fire the thing up, it'll be brand new. It doesn't hurt to sit discharged, but yeah, you don't want to fully charge a lithium battery, and then store it. Ideally speaking.
These rely on batteries have indicators showing state of charge.
I don't know. I don't know if they have an application. Some lithium batteries have like a Bluetooth app. You can tell a state of charge. Some don't. I'm really not too familiar with Reliant in general to speak toward it. Yeah. I mean, it's still. I mean, that's up to you. That's that's a user discretion kind of thing. I mean, if you know your state of charge on your phone and you're happy with that, then you know your state of charge on your phone.
Okay, but you don't have an app.
Right. Yeah, but if the manufacturer doesn't have an app, you really want some kind of battery monitor, or else you're going to have no clue the state of charge of your battery. 1 second.
Before we get too far along, for those of us that are not as well informed, so you're telling me that if you disconnect your batteries to change them, you do irreparable damage to the controller?
No, what I'm saying is whenever you disconnect a battery, ideally speaking, you don't want to have a charge source actively charging it. So we do recommend, for example, on our controllers that you would disconnect the PV input, or Bill said, pull the fuse on the PV input,
But if there isn't one,
or do it at night,
well, yeah, but if there's no fuse, so when you disconnect that controller from the batteries,
I've never had that cause irreparable damage or a controller, but it's still not advisable, right? So I have seen on the 3000i one setting get flipped, and I've had people, I've walked them through how to change that setting back. One of the EEPROM settings just flips because the higher voltage. I've never had it break a controller directly, but it's still not advisable.
so if you disconnect the power from the
Solar, right?
to the controller, then you can change your batteries.
Not without any worry. And the same thing is like you want to make sure you're not on shore power when you disconnect your batteries, because then your converter is going to be like, oh God, where's this power going?
Thank you.
Yes, sir. Long-term storage, I mean, I would say a month or more. You know what I mean? And it really depends again. If you're, I mean, it could be a week, but I don't think if you're staying for a week, it really would, you need to take that extra time to, program your battery and change the charge profile. Also, if you've been actively camping for a week or 10 days or a weekend, and you have a standalone charge controller, having it hold that absorption voltage every day for that week is going to really make sure those batteries are super clean and desulfated, prior to when you go camping again. So that's a good idea. If it's 1 week, but like a month, I'd say would be my long-term storage. You can get very familiar in how to change the charge profile. In the end, it's only one setting. Once you get your system down, or two settings, you can you turn that on, switch this absorption voltage back up, and everybody wins again. Also, just wanted to mention, Bluetooth is back for Blue Sky. Woo! So it's been a long time coming. We finally have a Bluetooth device. It's this little guy right here that connects to any of our charge controllers. Right? Clicks right into the RJ11 network. And then you just download the app for free. Right now, this isn't for sale. It'll be for sale in about 2 months. I do have a working app on my phone, so everybody can come play with it. It will be available for sale well before summer. We're just, we're wrapping up some of the injection molding for the case, because this one's just 3D printed, and a little bit of the back end stuff. But it does a whole bunch of stuff, everything from monitoring everything you're doing. It also does automatic data logging. And internally, it'll store 3 months of your data, 24 hours a day at a half an hour granularity. So you can see your battery voltages and your charge voltages and your input current. You can look at that in a tabular fashion. You can look at it in a graph. So it's really, really cool. You can change all your charge settings on it via the Bluetooth. I mean, anything you can think of, it's definitely on there. And so you can go back and look at your battery voltages over the last year, or anything past 3 months, by the way, you can get an SD card and just click it right in, and your time will increase. So you can have 2 years of data storage in there. 3 months internally, pretty much indefinitely if you get a little SD card and put it in there. But you can look at your voltages, you know, in your storage mode, or you're like, you know, my lowest voltage, you can zoom in and say, okay, you know, on average, what's my voltage when I wake up? On average, what's my voltage when, you know, at the end of the day? How often do I get into absorption mode? A lot. So it's in there, and I'd love to show it off because it's been a long time coming, but we finally have it. Any questions so far? Am I confusing anybody? So they do, trimetric. So yeah, you can get a BMS system for the Relion, is what Bill's saying. So, yeah, you know, not the BMS, I'm sorry, a battery monitor. So it's got the shunt, kind of like our system does. But yes, Relion does sell a battery monitor system. So if you have Relion battery and you don't want to use our shunt, you want to use, you know, their system, fine and dandy, you know, awesome. Thank you, Bill, because I wasn't too clear on that. Now, another good political conversation, right? Probably the biggest one out there. Series versus parallel. Which is better, right? Now, it's one of these things, right? Which is better. Now, when you look at combining arrays, right? Let's say, when I mean in parallel, I mean all the reds together, all the blacks together. The voltage stays the same, the current increases, right? In series, the current stays the same, but the voltage increases. You're just basically stringing them together, kind of like making 2 6-volt batteries or 12-volt batteries. Now, when you combine an array in parallel, basically the lowest voltage tries to dominate, right? So for example, I have 2 12-volt panels, they both have an output voltage of 18, right? Now if I put my hand over one panel, just even a single panel, I put my hand over a panel that has 18 volts output, that voltage is going to drop down like 17, 16 and a half, you know? You can lose about 7% of your voltage and your power of that panel. Now when you have 2 panels together, now this one's 16 and a half, this one's 18, the 18 is going to feed a little bit into the 16 and a half. Kind of like if you have 2 batteries. One's fully charged, one's dead. You can connect them together. Now the fully charged battery is going to try to feed the bad battery. And now it's not 100% so. It's not like a 100-watt panel will cause a load of 100 watts. It doesn't, you know, but it will try to, in general, it's going to try to like go into the lower battery. Now, if I have 2 panels and they're in parallel, and one's down to 16 and a half, and this one's 18, now let's just say, even though this might be a little dramatic, now they're both 16 and a half. So my total array production dropped by 7%, okay?
Would there not be a diode installed in both panels to prevent leaching?
I'll talk about bypass and blocking diodes in a second, okay? But as a rule of thumb, when you combine panels in parallel, the lowest voltage dominates, right? And speaking in general, when you shade a panel, its voltage is going to drop a little bit. Now that same panel, let's say 100-watt panel is putting out 5 amps. I put my one hand over that panel, that output of the panel, that one panel can drop to like 2.5 amps. So partial shading really does affect the output current of a panel a lot more than the voltage. Now if I have 2 panels in series, the lowest current tries to dominate. So, and there's some caveats I'm going to get to because there's a little bit ahead of this, right? So in general, in your most basic panel, right, your basic old school panel, now this is 2.5, this is 2.5. So now instead of in parallel, when I put my hand over one panel, I lose about 7% of the array's production. You know, if I put my hand over the panel in series, I'm going to lose about 50% of the array's production because the lowest current's going to dominate when you combine panels in series. Now, many modern panels also have bypass diodes installed, okay? And that helps that bottleneck from happening. So if you've got 4 panels in series, right, and you put your hand over one, you might lose that entire panel because the bypass diode is allowing power to flow around it, but it's not going to bottleneck the other 3, okay? So a lot of panels do have bypass diodes installed. Blocking diodes are more, they prevent, you know, basically it's what we call the blocking diode or anti-reverse diode. A lot of times they'll have them click in on MC4 connectors, or you'll have them inside a junction box. That prevents what you're talking about, like the 2 batteries, one battery from backfeeding into the other. But a blocking diode always causes a little bit of resistance, about a 0.5 volt of resistance, just in general, always. So you play this game between I want to lose 5% of my power production overall versus, the little bit of an imbalance between the two. The only time I normally recommend anti-reverse or blocking diodes in a parallel system is situations where people have panels on their roof and then they have a remote system as well, like a foldable ZAMP system or something like that. Because the reason they got this is so when they park into a tree, they can still run out and put this panel out. Now, if all that's connected into the same system in parallel, now this remote's going to try to feed in, you're going to get a draw on your roof panel. So they'd rather take a 5% hit on the roof all the time, but when they park under a tree, they can have the remote panels still hooked up to the same charge controller. Well, it depends on how many, it depends on, yeah, well, generally speaking, yeah. I mean, you talk about 18, it depends on what size panel, of course. But if you have 18 volts under load and you lose a half a volt, 0.7, maybe it's a little less. But in general, it's about a half a volt. And not all blocking diodes equal. If you do buy a blocking diode, get the one rated at 20 amp, not 10 amp. Because your overall resistance is going to be a little less while it does the same job. It's only like $2 more. Now, the advantages, people also on the advantages and disadvantages, right? Now you're like, well, why don't we go parallel for everybody? Because it's a little bit better for partial shading. Another reason why a lot of people go with, the series is the argument of, well, in order to charge, the input voltage has to be higher than the battery voltage, right? Just a rule of thumb. Now, that discretion varies between charge controllers. Ours is any higher. If your battery's at 14 and your input's 14.1, we're still charging, right? Different charge controllers, that wiggle room varies, on the input versus the battery voltage. It just has to do with the resistance and the actual design of the charge controller. Now, some people would say that if I wire panels in series, then when it's raining out and you get a really cloudy day, or the sun's coming in at an angle, then in that situation, my input voltage will still be higher and I'm still charging. Can't argue with that. It's a great point, right? But in general, even on a day like today, I mean, my panel's right here charging the system. It's still charging, right? Still rocking and rolling, and that's an 18 volt out. And you'll be able to look on the app. I'm probably coming in at like 15 volts right now, maybe 14.7 on a day like today. But it's still higher than the battery voltage. Another reason why some people would say, I like series versus parallel is the wire gauge. When you have higher voltage, you don't need as thick a wire when you combine all the panels together, right? And so depending on your input voltage and stuff like that, you might string 3 residential panels together, or 4, coming at like 150 volts. You have like a 10 gauge wire in and like a 2-aught, 4-aught coming out. You know what I mean? And that's fine. Your voltage resistance, so you do need more copper, larger gauge wires when you run parallel. Sometimes, of course, every application is different. It depends on the distance between the panels and charge controller. You're running 10, 15 feet, you're fine. It's probably okay. You've got, if you're living off grid and you've got your solar panels in the field over there, and or like a big rig, you might go the other way. So a lot of it depends on what kind of camping you like. And my person is, a desert monkey and just loves, sitting out in the desert. And they got a totally flat roof and partial shading is not an issue. Yeah. So it really depends. Like, I'm not saying series is bad. It is, as a rule of thumb, partial shading will be better, or a parallel system will be better with regards to partial shading versus series. But it really depends on what type of camping you do, and everybody's situation is different on what's on the roof and what's not on the roof. So I'm not saying one's better versus the other. Just kind of explaining, we also have the capability of having multiple controllers integrated together in a master-slave network. So you can have up to 8 controllers integrated together, so they can optimize arrays independently while cooperating as a single unit. So for example, I've had some people with motorhomes that are big enough to get to national parks. A lot of them aren't, national forests. But they'll have one array on the front and one array in the back on 2 different controllers. And that way they back into a spot, and this one's totally occluded. The front array is still operating at 100%. Also, it's common for people that have like a remote panel, right? And they start the shunt, they got their battery monitor, they want everything to cooperate as a single unit. They'll tie in a no bells, no whistles slave into our system, and that'll operate their remote panel when they want to have it happen. So they can just, they fold it out, they plug it in, and now, as far as your systems and your displays are concerned, it's one controller, but each one is optimized respectively on their independent arrays. So that's a very common thing to do, especially because a lot of I'd say the vast majority of your solar panel foldable kits don't have MPPT charge controllers. They have PWMs. I don't know of any, they're probably out there, but I don't know of any in particular that come with MPPT charge controllers. It's also very common on a Genasun controller, and I've got data sheets for it, but a lot of people will upgrade their ZAMP, or Go Power or whatever, PWM with one of our MPPT controllers. No bells, no whistles controllers. Although if you have a Blue Sky unit, I'd rather you get like a 1524 or one of our, no display, no bells, no whistles, and just tie it into your system and have that and everything cooperate together. That way you operate your stages, absorption, float, and all that as a single unit. If you have a shunt, that's transition. If you have a battery temperature sensor, it applies to all the controllers in the network. That's the way I'd prefer to have it happen. But just to let you know, we do manufacture charge controllers that can replace, and they're expensive, like $100. That can replace, because if you have a 100-watt panel with a PWM, you got a 70-watt panel, maybe 75. So why, you spend, those foldable kits aren't very cheap. Why chop your leg off? And it might not seem like that's a lot. Okay, so what's 30 watts? Well, 30 watts is about 2 amps, in real life. And that's about, 10 or 15 amp hours in a day. And that adds up day after day, So it's always go MPPT whenever possible. Any questions? Yes, sir.
Can you use an MPPT and a PWM?
Good question. Can you have multiple charge sources on the same battery bank at the same time? Right? Yes, you definitely can. Now, all charge controllers in general have 2 different modes. They either provide constant current, that's providing your maximum amount of current trying to raise the battery's voltage, or you're providing, CC is termed, right? Or you're providing constant voltage, CV, right? That's where you're providing enough current to maintain a voltage. Now, even your battery's alternator, right? Your car's alternator, when you turn it on, it's providing constant current, bulk mode, until you get to 14 forest, whatever your alternator is. At that point, you're maintaining 14.4. Now, let's say, for example, and I'll wrap it up. So let's say, for example, you've got 20 amps of solar available, right? The controller wakes up, woohoo! It's putting 20 amps into your battery. You get the absorption voltage, a little while later, now it's only taking 5 amps to maintain that absorption voltage, right? You're providing constant voltage, CV, at the absorption set point. Now, even though you have 20 amps of solar available, you're only giving it 5. Now, let's say you turn on a load. Let's say you turn on a 5 amp load. You turn on a load, that voltage is going to try to drop on you. So the controller sees the voltage try to drop, so it increases its output. Now your solar puts out 10 amps, 5 to the battery, 5 to the load. So it's providing enough current to maintain a voltage. Voltage goes up, it turns down its output. Voltage goes down, it turns up its output. Now, if you have multiple charge sources, let's say, our controller set point is 14.4, and let's say your Magnum is floating your batteries at 13.2, right? Our controller wakes up in the morning, woohoo! Now your battery voltage is below 13.2 at this point. So both you say you plug in shore power, whatever. So now, since your battery voltage is below our set point and the Magnum's 13.2, both controllers provide constant current. Both controllers are going to give max output, trying to raise the battery voltage. Now, once your battery voltage got to 13.3, above the Magnum set point, your Magnum's output is going to be 0. Because it's like, I'm going to 13.2. If the voltage is higher than 13.2, I turn down my output. Lower, turn up. So if the voltage is, your actual battery voltage is higher than any set point of your particular controller, its output would drop to 0. And our controller is continually going to try to go up to 14.4. Or vice versa. Let's say our controller is maintaining float voltage of 13.2, and you turn on the equalize function of your converter, right? Our controller is going to have max output to get to 13.2. Once your voltage gets above 13.2, our output drops to 0. Because it's just trying to provide enough current to maintain a voltage. So when we say multiple charge sources, the highest voltage wins. Well, whoever's trying to get the highest, that's going to be the target of that particular controller. You may not have enough juice to get there. If your batteries are heavily sulfated or they need more power, it's going to try to get there though, because it's going to reach to that set point. It's going to reach to the higher goal. So if your PWM is shooting for this and your MPT is shooting for this, each controller is just going to stop at that high point that it's particularly set to, depending on its charge mode and phase. Well, yeah, he's asking like,
futile because both reach that tempo and both kind of hit
right, so he's saying like, what if I had two charge controllers? Well, let's say, what's the benefit of having two controllers configured together in a master-slave network versus having two controllers have the exact same charge profile programmed into it? For the most part, they're going to cooperate exactly the same. Although the caveat of that is the wiring between those controllers and the battery might be a little different. So you might have this controller might have 10 gauge wire, this controller might have 8 gauge wire. And due to the resistance of the wire and the voltage drop, this one might observe a slightly higher voltage as compared to this one, and so they may make that transition at slightly different times. But if you had like big honking wires to a terminal block and all the resistance was identical, then in theory, yeah, they'd all transition exact the same time.
What I was thinking was, why don't you connect it to panels in series or something?
Well, if the input wattage is he's asking like, I'm not sure exactly, but if your input wattage is the same, series or parallel, and you have a good MPPT charge controller, then your input to the controller is going to be the same. Like if you have 2 panels in parallel, perfect conditions, and you have 2 panels in series, perfect conditions, you're going to have the same number of watts at your charge controller. But your battery voltage remains the same, right? So he's asking like, well, what if this controller has 10 amps out and this controller has 5 amps out, right? Well, again, the controller with 10 amps out is going to have a little more resistance, so it might make the transition a little sooner because it's going to observe a slightly higher voltage at the controller versus the batteries, if this one has 5. But if the one that has 5 amps out has larger wires, then it might actually see, or smaller wires. So you play the resistance game between what the actual voltage is as observed at the charge controllers. Yes, sir.
This might be a dumb question, but let's say I only have 10 volts pushing, let's say 40 amps. Will that ever charge a battery, a lithium battery up to 14
Are you saying
full charge?
Are you saying 10 amps?
No.
Okay.
No, a lot of amperage, but low voltage.
So
Less than
I understand.
14.
I understand. Just charging batteries in general, right? Think of voltage as pressure, okay? And so any solar system, right? Just about in the world, let's say some weird panel, if the input voltage is below 15 volts, something's wrong. I mean, maybe in this condition, okay, I'm down to 14 and a half or 14. Okay, I can see that happening. But on troubleshooting, I get the calls all the time, like, hey, Ryan, my controller isn't charging, or my controller's charging at a very low rate, right? First thing I have them do is look at their input voltage, either on the Pro Remote or physically with a voltage meter. And if their voltage is under 15 and it's not raining or it's not like any kind of sun,